Hi, welcome to the fifth tutorial within the series of tutorials on Linux, within the wider series of tutorials on the introduction to software in robotics. In this video we're tackling networking. There's three things we want to go over in this video. Number one is just to talk about the scope of networking that will be covered, because it's a very wide topic and we're only going to focus on a super narrow part, but with some context. Then we'll go over the basic networking concepts that we need, and finally we'll talk about connecting to a different computer, where that computer could be the one on the robot. That's why we're doing this. That's our final goal. By the end of this video, you should be able to connect to a different computer. So not just connect to the, connect to the internet. Of course, there's something similar, but yeah, connecting to a different computer. The internet is a series of computers, but when you do things manually, it's like slightly more involved, basically. Yes, let's start. So the scope. Overall, networking is a serious topic. Now, a serious topic means it's just, what it basically means is that there are experts in this field that have been doing primarily this for years and years, and they have, very large amount of knowledge about many particular things. Now, I am by no means an expert here. I wouldn't even call myself the intermediate person in networking, but more like a advanced beginner, basically. So why is this a serious topic? Well, it requires the background in many different things to begin operating systems. By this I mean, all the things like file systems and stuff like this. Every single bit of it pops up. Managing of hardware, all of it pops up in networking. It's I'm gonna break this down into specifics in a bit. So one of these things is parallelism, and what this means is parallel execution. So this could be that you have multiple processes running on a single computer, on a single CPU, but still they do not share the same resources. They're doing their own separate things, and they somehow need to be managed to not step on each other's toes, essentially. And in the more in the wider sense, parallelism is you have many different computers on possibly different networks, and then they all do stuff in parallel. If you have a very big application like a humanoid robot, for example, you might have multiple different computers with multiple different processes on them, and they all need work in concert to achieve a common goal, which would be, a humanoid robot takes a glass of something and passes it to you. Then yeah, these processes very often need to communicate. This is where networking sort of comes in, but this is a wider topic of how do you communicate on a single computer as well. There's shared memory, pipes, various kinds of message passing that doesn't have to be over sockets. And within this field, you sort of see what are the needs, what are the communication needs, and how do you specify the way these processes communicate. You sort of you accustom the communication to the use that you need. There's various different trade-offs with these things. So, that's the reason why it's a topic, really, of course. And finally, there's the full internet stack. Everything from electrons to protocols. So you could be just doing networking cards. How do we accept messages faster? How do we add more? Well, not messages yet. How do we just have increased the bandwidth? How do we ensure that the zeros and ones that are somehow encoded, as a square signals, there's ups and downs of voltage on a wire. How is this? How can you add more of them on a copper wire, or over as photons or whatever it is? And then the computer needs to take this in. It needs to sort of understand the message that these bits compose, blah blah blah, and then you reach the point where all of the rest below you works, and you have a particular communication protocol. So sort of like we tend to initiate conversations with hello, good day, stuff like this. The computers do that as well, except it's so formal that if any part of it doesn't work, there's no communication. It's broken basically. And again, for different types of communication, there's a different protocol. One very famous protocol is HTTP, which is it's used on the web. You click on a website. What actually happens is there's a connection happening from your computer through the web of computers, that is the internet, to the computer that serves this website. And then there's your computer tells it like a specific message, and the response is basically the contents of the web page. And I mean, of course, it's like there's a lot of things going on there. But anyway, networking, an expert in networking knows all of these things. And all we want to do is just to connect to a robot. So we'll introduce the smallest possible amount of these the concepts so that we can understand and debug a connection. Basically, that's all we want. But I wanted to say, there's this particular rabbit hole goes incredibly deep. Okay, basic networking concepts. So number one. The local area network is not the wide area network. And by this, what I mean is, a wide area network is basically the internet, essentially. Or, smaller networks that are then connected, blah, 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 to form the internet. Okay, well, on the other hand, the local area network is, you're at home and you have a home server or something. You might have a few phones and they're all connected to a router, and these computers together form your local area network. If you're at the university, there's and you're using some server there, and which I don't know, only the staff and the students have access to, then they might be all in a single local area network. There's sort of intermediate steps of sizes there, but the basic difference is that computers connected via LAN are not connected to any other computers. They're not on the internet in the broad sense. There's no surprises. Yeah, very often a local area network can be completely static, so nothing changes. But the mechanisms that are outlined here, of the parallelism, the particular kind of inter-process communication, the particular protocol being used, and so on, all of these apply in the local area network as well. And sort of like I discussed with Linux, it's customized for this and that, but once you know it, you can apply it to many different things. And once you know the sort of these some of the practical know-how of networking, of connecting computers together, you can just use that over and over again and slightly modify it. Okay. The next concept is IP address. So computers are, they're rocks with copper and some electricity. There's no intelligence there. It's a glorified calculator, basically. Although we anthropomorphize them, to make things a bit easier to understand. But everything needs to be numerically specific. So two computers are connected together. They need to know where the other one is, especially if there's a network of multiple different ones. And the IP address is the address, basically. That's the designation of one computer in a network. Now there's multiple different IP addresses. If you're on a local area network, that's one address that's used just for this local area network. And then if you're connected to the internet, you're assigned a different IP address that's used for the wider area network. Yeah, and your router is the one, because only your router is connected to the internet and understands how to contact all of the different websites. So it handles that part for your computer basically, and then that has the same internet address, and it sends the particular messages to a computer on LAN. However, that's not enough, because your computer is a collection of programs running at the same time. So what you need, if you're using a web browser, you need to, and I don't know, simultaneously you're downloading or uploading something else. You're synchronizing to your home server over your local area network, all of these different processes simultaneously use your network card. That's the same computer. So you need to differentiate between different programs running on the same computer, and for this you use ports. And I think they go up to like 65,000, from 0 to 65,000. Everything up to 1024 has a predefined meaning for the protocols that you you have to have for your protocols you need to have for the networking to work basically. And all of the upper numbers are user ports. So anyway, the point is, if you want to connect to a different computer, a program running on a different computer, that's really what you want, then you need the IP address and the port combination. And we'll see some examples of that later. Then I'll propose the protocols. So there's HTTP would be the application layer protocol. So how the communication happens. TCP and UDP are sort of one level below, where we specify the lower level packets. How do they travel? How do they behave? Right. So you ask for a web page from a web server, and it has a lot of the images. Maybe you're watching a video and so on. Basically, a lot of data. Not all of this will simultaneously be transferred in sort of one big string. It needs to be broken down so that the other layers can, and this layer can ensure that all of the packets have arrived as they should have. It's basically you break down the problem into bits. That's what we want. And so these two protocols are they're managing everything on a packet per packet level, let's say. Now I'm oversimplifying all of this, but what I'm getting at is that TCP will check that the content of every single packet has arrived exactly in the state that's been sent. Now there's some fancy, if you've ever had an information theory course, you know a bit about how you can detect errors in the bit stream. The idea is you add some additional bits, and then you perform some math task on this, and the sum of these extra bits and the data bits need to add up. The equation needs to be correct, and then that the message has traveled successful. So TCP, if there's an error, TCP will send back a request saying, hey, this particular packet is broken, please send it again. So for most things, that's really what you want. If you're sending a PDF, you don't want the metadata in the PDF to be broken, or a sign in your mathematical equation to be flipped, and you're fine with waiting a bit if an error occurred. Now UDP, on the other hand, just streams all of the packets one after the other, and if there's an error, tough luck basically. So why do we have this? Well, sometimes we want to maximize the throughput of data, and we don't care if a particular packet has dropped. So for example, when you go to YouTube and you stream a video, that stream will be via UDP. you know, you have a lot of the FPS. If you drop 1 FPS, doesn't matter. But if your connection is 5 times slower because of TCP, now that's an actual problem. So those are the two main protocols in the one layer below the application layer. And the IP addresses and how that's handled, that's a layer below, but who cares? Okay, and finally we have sockets. Now a socket is a particular piece of software where you programmatically manage the sending, the receiving of messages. So essentially you say, I have a TCP or a UDP socket with these or that properties, and you know, write your program which implements one of these application layer protocols. And you know, in for example, in robotics, if you use ROS, there will be a particular kinds of different kind of protocols. Again, like essentially every single communication situation can have its own sort of perfect protocol of the trade-off between the safety and the whatnot, or like the particular messages that are being sent. You know, you could say, okay, I can serve you a file, I can start a stream, and if you give me some magic number, I'll, you know, run a function basically. And you know, how do you say each of these things? You enumerate these actions by some number essentially, and then once that number is received, the correspondent executes something depending on that. You know, protocol could be very, very simple. Okay, so yeah, so it's good to know the socket is probably the lowest level anyone goes in the, you know, for your standard programming needs, and it's good to know that it's out there and sort of the terminology with it. Okay. And now let's finally talk about now that we have this terminology out of the way and we know that we're in over our heads completely, we can just simply try to connect to a different computer. And here is a list of the commands that I want to show. So if you're running a network manager, that's a part of the OS on what system it's a command that you might or might not have, and it will list out the different connections that you have along with the IP addresses and the ranges and so on, what's the route. So the Docker will have its own network. We have our local host network. Now I'm not connected via Ethernet, so there's nothing here. And this is the Wi-Fi. Now I'm not blurring any of this out because I know that this is local area network information, and that it's like, I mean, unless you know my IP, none of this means anything. And of course, I'm not showing my real IP. And there's some other stuff over here. So how you can, you know, connect to a different network this way, or disconnect, or like disconnected the device, or whatever. You know, for daily use, if you're in the terminal most of the time, like I am, you use nmcli, command line interface. One thing I want to cover here is the connection editor, which is actually a graphical interface where if you, let's say, want to add a new connection, and this is, you know, when you want to connect to something on LAN, very often it will be a static IP address, so you want to go over something like this, and yeah, say over which device you want to go. One of these is my Ethernet cable. The other one would be when I connect via USB-C. That thing can handle internet as well. You don't need any of this. You don't even need to select a device because both of them will be fine as long as they, you know, provide Ethernet connection. That's the physical layer of the networking stack. The proxy we don't need. Since it's a LAN, we don't need the IPv6. It's always IPv4 on LANs, as much as I know anyway. In theory, you select the type of connection you want, and in this case it would be manual. And now here you would type in some kind of an address that you give to yourself. A net mask, 4 lines, it's this number. That basically means that these up to these numbers will be fixed, and then this last number will change up to 255, essentially. I'm pretty sure that's right. And in most cases the gateway doesn't mean anything, but I tend to put in the number 1. That's usually, if there is something allocating addresses, like a DNS, that's what the DNS does, then typically it's the first thing on a network. But I mean, if it's a manual connection, this shouldn't mean anything, because yeah, on one computer you set a connection where you add an IP address manually, on the other one you do that as well, and then you know which IP address to look for to make a connection. Okay, so this is how you would create another connection. Now, since this is between the computers, we don't need the ports yet. If you don't have nmcli, you can use IP address to see on which interface you have which IP address, basically. And of course, it has a multitude of different things. You can see the route between the two different computers and so on. But we don't need any of this to just connect to a computer. Now, sometimes there will be a DNS assigning different IPs, and you won't be sure which IP your computer got or another computer got. And the easiest way to find out what's on the particular network, I mean, you know your IP, what IP address, that's okay, anyway. But you don't know the IP of what you want to connect to. So ARP is the protocol that's used to essentially for one computer to see other computers on LAN. It's incredibly non-intrusive. That's why I'm selecting this to use. If I run this on my my router, I see that this is my router. This would be some computer, this is some computer, and this is my computer, if I'm not wrong. No, my computer is .9. Okay, so it didn't look for this. Maybe if I give it a bigger number, 32, whatever. You just use the number 24. I forgot what this means actually, but it should be, yeah, okay, with 256 hosts. Okay. It said, okay, maybe the MAC address you shouldn't see. Whoops. Please don't hack my computer. I block my ports, but don't try. Anyway, so that's how you would find other non-intrusively. Now let's say that you have a manual connection and you want to sort of check whether this other thing is even online. So then you use the command called ping. And now I'm going to check for one computer that I have. That's my home server, and it is. This means that it's on. So ping is I send you a particular a packet, and I receive a packet back from you under the ping protocol. So now if I see that there's a time it took for this to happen, I know that okay, clearly the packet got back to me. If I put in something that doesn't exist, then nothing will come out, and it's gonna say destination host unreachable. Okay, you can also check whether you yourself have internet connection. So I'm gonna use that. So you just type in an address. I, out of principle, don't want to type in Google, but that's a different story. Anyway, well, I'm uploading this to YouTube. Thank you, Google. Thank you, Alphabet, for letting me do it. I'm still pinging Arch Linux, though. Anyway, maybe I should ping them just to increase more traffic. No, whatever. Yeah, because sometimes you have a connection and it says that you should be connected to the internet if you're, connected to your home router or whatever it is, or you're in the lab, and yeah, this way you check that you have internet, even if you don't have access to opening a browser, because I don't know, you might be doing this on a Raspberry Pi or something, on a robot. All right, and finally, we're gonna do. Oh, I could have added SSH into this as well. So if you have the SSH protocol, the remote shell protocol, then you can connect to something else. In this case, this is my home server. As you can see now, it has a different name. Now it's a machine. The other one is Mahuin. Yes, I'm very creative with this. Okay, I normally have automatic tiling, but not now. What is this? Okay, this is annoying. I don't need that anymore. I don't need this. Okay, let's just have them normal tiling. I think I can move my face a bit down. Can I? Should be able to. Apparently not. Yes, we can do it this way. Okay. So, as a sort of sometimes you don't have so ping might work, but you might not be able to verify that you're allowed to make different types of connections. And the protocol you're running could be giving you all sorts of different errors. So what we're gonna do is we're gonna use netcat. That's an incredibly powerful command that can do many things, some of which are bad and that you shouldn't do. So you don't use netcat unless you know what you're doing, except for this one particular use case is what I'm trying to say. Anyway, with this I can create a socket, a connection that just and here try to connect to it with like a bit. Yeah, I can do a bunch of things with this. Anyway, I will give this is listen, and let's make it UDP 192.168. That's its IP address, and use port 6666. Run this, and now I want to not listen but connect. That's the default with UDP, and I'm just going to type in the same IP address and port combination, and now there's message passing happening. So now I know that if I create I open a port, a UDP port on this computer, I can connect to it from this computer. That way you check if there's firewalls happening or something like this that could end your connection basically. And you can do the same with TCP, which is the default, right? Yeah, sometimes you have to do it the other way too. So I was at 9, I'm listening, 9, just connect, and it works the other way too. So this, like, if this works, then pretty much everything should work. Now, your particular applications very often have, they either ask for the OS to assign them any port, or they might have a particular port that they use. So you can check for the specific port. Normally the firewalls shouldn't really matter if you're over the local area network. That's something that's you basically block off ports coming out from outside of your local area network. Usually, you can set whatever you want in your firewall. Okay, I think that's it for the networking that we're gonna need. So now you know how to. Now you know that networking is complicated, and that it's a big topic that has a lot of interesting things in it. If the only thing you want is to connect to a different computer and use sort of the protocol someone defined, now you know how to create a connection, use that connection, and you know all of the concepts for why you need to do all these different things. So hopefully you learned something today. And yeah, you're now able to, you know, debug your connections, which if you don't know all of these concepts, can be incredibly tedious to figure out, you know, what could the problem be. All right. See you in the other tutorials.